All right, chemists, this is actually take 3 for this video of the octet rule. So if we're using our SAT skills, we think of the OCT prefix. Oct, like octopus or octagon, has the number 8 attached to it. And this rule is important because nonmetal atoms combine so that each atom has a total of 8 valence electrons. So this is true when you count shared and unshared electrons. And the exception to this is H. Hydrogen tries to get only 2 valence electrons. So if you remember back when we were talking about ionic bonding, atoms gained or lost electrons, so they would have the electron configuration or the electrons of a noble gas. Same is true for covalent bond, except they're not gaining or losing. They're sharing until they get to a total of 8. So let's play this out a little bit. We have ethane right here, C2H6. I'm going to do the Lewis dot for this. I'll walk it through. All right, so we have, remember, we put 1 on each side until we get pairs. So each C has 4. I have 6 H's. That's a lot of H's. All right, and put 1 valence electron for each of them. Now, my first step is to connect the atoms that want to bond the most. In this case, it's carbon. Each carbon wants to bond 4 times. So now I count 1, 2, 3 valence electrons on this carbon, 1, 2, 3 on the other. So I have 6 hydrogens, so this works out that I can connect them all, and I have no lonely electrons. Now this looks terrible, and I can't even figure out what's going on here. So let's put it all together. So C, H, 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 H. Okay. So this is the Lewis dot structure on the right. That combines what we did on the left. So if I draw a circle around the carbon atoms and all the valence electrons associated with it, I can see that each carbon has 8 valence electrons. So it's happy. It has the electron configuration of neon. But what happens all of a sudden when I take away some of those hydrogens? So now I have 2 carbons, still with the 4 valence electrons. Now I only have 4 hydrogens. All right. So we start the same way. We start by connecting the atoms that want to bond the most. So connect the 2 carbons together. But I still have these 6 valence electrons that need to be paired up. And I only have 4 hydrogens with which to do it. Well, it turns out that you can make a double bond between the carbons. So I can pair up those 2 valence electrons. Now I only have 2 valence electrons here, 2 valence electrons here. And I can pair them up like this. Now, again, that looks really difficult to understand, so let's just put it together. Well, now, instead of 1 bond connecting the 2 carbon atoms, I have 2 bonds, which means instead of 2 valence electrons, it's 4 valence electrons. And then I have 2 hydrogens coming off each. Now, if you try to do it without the double bond, you would get something like this. And we can look immediately and see why this is wrong. Let's do our check. Well, each of these carbons has 8 valence electrons associated with it. We can do it here. This one's good, but this one only has 6 valence electrons. That is very unstable. So this is no good. For the last one, I'm not going to do the whole Lewis structure. Now we lost 2 hydrogens, so instead of a double bond, we now have a triple bond. And you can also represent it in terms of the structural formula like this. Okay? But the same thing applies. If you notice, even with our triple bond here, each carbon has 8 valence electrons associated with it. Now, I kind of want to do another one here. I want to do, what do I want to do? I want to do CnH3. All right, so if I draw my Lewis structure, you come out with this. Again, if you circle your center atoms, they each have 8 valence electrons. Now here, the nitrogen has a lone pair. It's not part of the bonded pair, but it still works. Your goal is to get to 8 valence electrons. All right, so just some discussion notes. So we learned about the honk 1, 2, 3, 4 rule, and now we have the octet rule, and both of them help you figure out how atoms bond together to form molecules. Both honk and the octet rule can be satisfied using double and triple bonds appropriately. So that means that, for example, if your carbon only has 2 bonds, then the honk 1, 2, 3, 4 rule tells you that you need to have 2 more. The octet rule, if it only has 6 valence electrons, you know it needs to make more bonds. Here's one that I need you to pay careful attention to, is that it is not possible to create triple bonded oxygen compound according to the honk 1, 2, 3, 4 rule. You might want to try, but I'm going to encourage you not to do that in this class. It is possible, but for this class, we're going to keep it as oxygen only making 2 bonds, just like H, F, and Cl only make 1. And like I said, there are exceptions to the bonding rules laid out here. Those are ones that you'll learn about in higher level chemistry courses. All right, so coming back to the question, in what ways can atoms make covalent bonds to form molecules? Well, they form covalent bonds by sharing electrons until the octet rule is satisfied. Again, hydrogen is an exception. Atoms can form double and triple bonds to satisfy the octet rule. And when covalent bonds form, each atom resembles a noble gas in its electron configuration.